Hello, I'm Lily, and in this video, I'm going to explain vector and scalar quantities and adding vectors in one dimension. So first, we will start with definition of vector and scalar quantities. So we have vector and scalar. When we talk about vector quantities, they have both magnitude and direction. But scalar quantity only have magnitude. What does it mean? For example, for scalar quantity, one example is mass. For example, mass of one object is 40 kilogram. It's meaningless if I say mass of this object is 40 kilogram to the right or 40 kilogram to the left. If I'm talking about temperature of a room, I say, for example, the temperature is 20 degrees Celsius. I can't say the temperature is 20 degrees Celsius to the north. But what about vector quantity? Vector quantities have both magnitude and direction. For example, I say, I ran 10 kilometers to the north yesterday. So I'm talking about magnitude, that is 10 kilometers, and I'm talking about the direction that I ran, that is to the north. So example of vector quantity I can say is displacement. Displacement means change in position. But if I say that I ran 10 kilometers yesterday, it means the only data that I'm giving you is about magnitude. I'm not saying anything about direction. So in this case, I'm talking about a scalar quantity. Let's say I started from point A and I ran to point B. And this one is 5 kilometers. Then after some rest, I continued running another 5 kilometers. Right now, and if I show the direction here, if I say here is north, south, east, and west, I can say I ran 10 kilometers to the east. So I'm talking about a vector quantity. And as you can see, I started from point A. This is my start point. And if I name this from point C, this is my finish point. So the change of position for me is from point A to point C. So if I want to show it, this is the change of position for me. And if I use one arrow, actually I can show the direction. We name this quantity displacement. And displacement actually is change in position. And definitely, as you can see, is a vector quantity. So I'm giving you another example. This time I start from point A and I run to point B for 7 kilometers. After that, at point B, I decide to return. So I run for 3 kilometers. Let's say this one is 3 kilometers. And I get to point C. In this case, if you only want to talk about the magnitude, you say, okay, 7 kilometers plus 3 kilometers is 10 kilometers running. It doesn't matter which direction I ran, The only thing that's important is the magnitude. So when we only talk about magnitude, we say we are talking about distance traveled. So distance is a scalar quantity. But if I ask you, okay, what's the displacement here? For displacement, if we look at definition, is change in position. So where I started and where I finish, I started at point A. This is my start point, and I finish at point C. And this is my end point. So, and because I'm talking about displacement, I'm talking about a vector quantity. Definitely the direction is really important. So I need to connect point A to C. It means my start point to my finish line. Direction of arrow is from the start point to finish line. So is this. So what's the magnitude of this one? Is 4 kilometers. What's the direction? If we look at this guide, the direction is east. So I ran 4 kilometers to the east. And right now I'm talking about displacement. That is a vector quantity. So adding vector quantities or subtracting vector quantities are totally different with adding or subtracting scalar quantities. And we usually consider one direction as positive direction and the other one as negative to help us to do calculation. Let's look at fit simulation to help us to understand better. Okay, right now we want to talk about vector quantities and how we can add them together. Let's start. I choose a vector like A. I put it here, and as you can see, my vector A is on x-axis, so it doesn't have any y component, so its x component is 5, whatever our unit is, let's say 5 meters, and our y component is 0. And we want to consider one direction as positive. And here I want to say that right is positive. So I choose another vector. This time I choose vector B. I put it here, but I want to show it at opposite direction. Right now, if you look at vector B, it's again, it's on x-axis. Its x component is negative 11 and its y component is 0. So you see, when I'm talking about vector quantities, I use arrows to show direction, and also I can use, when I show a number, I can say, for example, A is 5 meters to the right or positive 5. If I define that, right direction is positive. Or I can say vector B is 11 meters to the left or is negative 11. If I already define that positive is right and negative is left. Right now, I want to look at the y-axis. Okay, right now I have vector D. In this case, the vector D doesn't have any x component. It has only y component. And its y component, if we say upward direction positive, its y component is 7 meters and it's positive. And I show another vector that is E, and I want this one to be negative. So vector E, again, you see it doesn't have any x component. It only has y component. and its magnitude is 9 meters. But if I want to talk about both magnitude and direction, I can say negative 9 meters or 9 meters downwards. As you can see so far, I talk about different vectors, but all of them are on one axis, x-axis or y-axis. Because of that, these vectors are one-dimensional vectors. In next video, we talk about vectors which are on a plane. So it means they have x and y components at the same time. Okay, let's learn how we can add vectors. If I have, again, vector A, I walked 5 meters to the right, and then I walked another 5 meters to the right. The total distance that I travel is 10 meters. And then I return. So from this point, I return to my original point. It means I travel another 10 meters. Again, if I want to talk about distance travel, it means I travel A 5 meters plus B 5 meters plus 10, 20 meters. The distance travel is 20 meters, no direction needed because I'm talking about a scalar quantity, the distance travel. Right now I want to look at displacement, or I want to look at a vector quantity. So just I'll put C back here. So I say I travel 5 meters to the right, and then I travel another 5 meters to the right. So it means totally I travel 10 meters to the right. And then I want to return. So I travel 10 meters to the left. So if I add this, what happens? So right is my positive. So I show it with this. So it means I travel 5 meters to the right, and then I travel another 5 meters to the right, and then I travel 10 meters to the left. So it means that 10 meters should be negative. So my total displacement actually is 0 meters. And if I want to show on the diagram, so I started from point A, I went 5 meters, then I got another 5 meters. Okay, if this one is point A, and then I return to my original point. That is. Right now, if I want to show displacement in this case, displacement is from original point to the end point. So it means my displacement is equal 0 meters. Let's look at another example. This time, let's say I have this vector that is 10 meters to the left. And then I have other one still moving another 10 meters to the left. And then at this point, I start moving to the right just for 5 meters. So let's look at this. So I moved 10 meters to the left, another 10 meters to the left, and then 5 meters to the right. And I want to consider right as positive direction. Let's see how we can add these vectors. So as you can see, we have 10 meters to the left, another 10 meters to the left, and then 5 meters to the right. Still, I want to say positive direction is right. So right is positive. When I walk 10 meters to the left, it means it's minus 10. Another 10 meters to the left, it means plus. another -10. And then I start moving 5 meters to the right, plus 5. So the answer actually is so it means the magnitude is 15 meters. So my displacement magnitude is 15 meters, but negative actually shows my displacement is toward left. Why? Because positive direction is right direction. Right now I want to use arrows to show it. This point is our start point. And this point is our finish point. When you want to show the vector sum of these 3 vectors, 10 meters to the left, 10 meters to the left, and 5 meters to the right, you start from start point and you draw one arrow from start point to finish point, and the direction is towards the finish point. So the size of this one is 15 meters, and as you can see, it's towards the left. I want to use 2 methods to add this vector. One is just saying, okay, right side is positive, so A, that is plus 10, and then 5 again is plus 5. This one is to the left. We know right side is positive, so plus minus 5 and plus minus 2. So it's equal to plus 8 meters. So it means the magnitude is 8 meters and positive shows that is to the right. So I can say plus 8 meters or 8 meters to the right. Or I can use drawing. So I say I start with vector A. I draw it. I draw a vector parallel and same size as A. And then I add vector B to that. So I start vector B from this point, head of this, and this one is 5 meters. This is my vector B. Again, from head of this one, I draw my vector C. So from head of this one, I need to go back another 5 meters. I get to this point, and then I have vector D that is 2 meters to the left. Again, from head of this one, I need to go 2 meters again to the left. Okay. So the sum of this is from start point. This one is start point, and head of the last vector is actually our finish point or finish line. The sum of these vectors is a vector that starts from start point and ends at finish point. And this vector is sum of all this vector, and it's 8 meters, and as you can see, it's to the right. So we have 2 methods to add vectors here. I hope you found this video helpful, and thank you for watching.